Hi guys, for you guys who doesn't know me, my name is Melvin. I'll be curating and covering a series of Form 4 and Form 5 KSSM syllabus chemistry for students that need assistance in certain chapters like chapter 3, more calculation, in chapters that are particularly harder like chapter 3 in Form 4, maybe chapter 6 salt, acid and base, and probably redox chapter in in Form 5. So let's hop into Form 4 KSSM syllabus chemistry, which is about the mole concept, chemical formula and equation. So for this particular chapter, there are a couple of things that the students should know beforehand, before hopping into doing all these questions, which is the interconversion of the mole concept, from mole to mass, from mole to volume, or from mole to number of atoms, or number of ions, or number of particles. So the idea is simple, right? That the normal currency, which is the base currency, the base unit and the base matrix for this chapter, or any chemistry calculation question, you need to find the number of mole of that particular chemical substance before you can find other things like the mass of it and the volume of the chemical substance. So let's start off with what it means by a mole and other things in this chapter. So basically, also don't mind me pardon, because I'm using mouse. I haven't buy a mouse like a writing pad yet, so probably the writing is gonna be quite bad. So just excuse me. So let me start off with another pen and explain what it means. Alright. So before going into the questions, you need to know a couple of things. The first thing is mole. Right, this is the center base of the common matrix and the common unit used to calculate anything in chemical substances. So for mole, generally we need to change everything to mole. Let's say you are given mass of anything. You can given mass of sodium. Let's say it is 2 grams. Right, the right side is mass. I explain the arrow, what it means by the arrow, the mass. So if you're given 2 grams of the mass, 2 grams of any chemical substances, let's say sodium, right? You're given sodium, and you need to convert it to mole, because the base unit for chemical substance is mole, because it's easier for you to convert and then calculate the mass or the volume. You need to calculate the mole. So usually the question or any questions, they give you the mass of that particular chemical substance first, and you need to change it to mole. How do we change it? The idea is simple, right? Let's say, I'll give you any number. I don't memorize the RAM, which is the relative atomic mass of sodium. So let's just give it 11. Alright, sodium is 11. So divide by 11. So in order for you to change from mass to mole, remember this is very important, because usually the question gives you mass, you need to change it to mole, is the mass of the chemical substance divide by its RAM, which is relative atomic mass, right? So let's say sodium is 11, so you get 11 divided by 2 grams divided by 11, so you get any number, you get x, value x, and x will be the number of mole. Because in order for you to change the value, right, you need to divide by its RAM, which is from the mass to the mole, from the right side to the left side, which is to the left side is the mole side, right? So divide by RAM. So let me put this as, delete this first. So then students will ask, how do you change mole to mass? So the conversion is, if from mass to the left side to mole is divided by RM, of course you take the mole. If you want to change the mole to mass, you take mole times RM, then you get the mass. So basically is that you time for this, right, to the right side, you need to times the RAM. And this is just for one part. The interesting part about this chapter is that the most interesting part about this this chapter is that there's a lot of like conversion. You need to convert from mole to like volume, or from mole to number of particles, number of atoms, or number of ions, or number, or like the mass. So you need to remember a couple of it, but the most important one is from mass to mole and from mole to mass. So this is the one part. So from mole to like volume, right, there are two things. There are standard pressure, standard room temperature and standard pressure, and one is so basically one is standard room temperature or the normal room temperature. The normal room temperature is 24. You must always remember it's 24 times 24, and another one is the standard room temperature, and the standard pressure is 22.4. So usually the questions won't usually ask you 22.4. The more common one is times 24. And if you're given the mole of, let's say, any substance, chemical substance, let's say it's like 0.1 mole, and you times 24, basically you get like 2.4 mole. So basically you get the normal, you get the basic matrix of the chemical substance, which is the mole of the substance. Then you multiply the volume, the number of the volume, which is the standard number of the room temperature, which is 24. So you will get 24 times 0.1, you will get 2.4, and 2.4 is basically in the unit of dm cube. Because volume, they usually use dm cube. Alright, so let's go to the next. Up here, done with volume, the next one is number of atoms, or number of particles, or number of ions. So usually what you do is you usually take, wait, let me clear this first. You usually need to get the number of mole, and then in order for you to achieve this, you need to get the number of mole of the chemical substance, and then you multiply by the number, or the Avogadro number, which is 6.02 times 10 power 23. So the Avogadro number is basically a standard number for you to calculate the number of particles, or number of atoms, or number of ions. So how do we determine how much, how many number of particles are there in it? So I'll give you an example, right? So let's say the chemical substances is given you 0.5 mole. You just need to take the 0.5 mole and multiply by 6.02 times 10 power 23. Then you get number of x, and that value x will be the number of particles or number of atoms at the end of the day. So yeah, basically that is the basics in this particular chapter. But there are different types of questions. Some questions will ask you maybe tougher questions, like it will ask you to calculate how many numbers of atoms or ions, and in a compound or a complex compound, it can be, let's say, zinc carbonate, zinc carbonate, or any other compound that has like multiple atoms, like zinc carbonate, right? You have zinc, because zinc carbonate is Z, and okay, no, zinc carbonate will be the same one. Let's give you another one. Let me think. So okay, let me give you an example. So let's say it is ferrum 3, okay, combined with carbonate, CO3. So these two, if you convert, you will actually get Fe2 CO3 and then 2. So in this particular example, in this instance, what you are supposed to do when you calculate the number of atoms is, it is not just given 0.5 mole, then you times the Avogadro number, right? It's not just this, because in this particular chemical substance, you have not only one atom. If you are about to calculate the number of atoms, so you need to know that Fe2 contains 2 atoms, and wait, this is 3, and CO3 contains 3 atoms as well. So together, this is like quite a lot of atoms, or like together it is called an ion. And there are many types of complex like ions, like atoms or number of particles. You just need to combine it together and calculate the number of and multiply the Avogadro number, then you get at the end of the day the number of particles or what the question wants. So let's hop into a couple of questions and let's analyze the question, right? So for this question, let's see, right? Number 5, and I take it from some reference book of mine that I bought during SPM time. So number 5, which of the following substances has the higher number of atoms? So the important keyword here is highest and number of atoms. So note that it's number of atoms. So we need to calculate which atom has the basically highest number of atoms when you multiply it with the Avogadro numbers, which is 6.02 times 10 power 23. So wait a minute. Alright, so 0.1 mole of carbon. So the idea is the lower number of your mole will be the lower number of your number of atoms, because the number of atoms is derived from the number of mole multiplied with the number of Avogadro. So A with 0.1 mole of carbon is definitely out. B, 0.2 mole of zinc, this is also out, because we know that 0.4 mole or 0.3 mole is higher than 0.2 mole of zinc. So B, A and B is definitely out as well. So now we have a bit tricky, C or D, right? So people who usually don't care about the number of atoms or things like a diatomic molecule or monoatomic atoms or things like that, they don't really care about whether the substance together carries 2 atoms or 1 atom. The difference here is for neon gas, although it is 0.4 mole, the value of the mole is higher than D. That is supposed to be that the number for atoms for neon gas is higher. But note that was one tricky catch here, is that chlorine gas and neon gas, the difference is neon gas belongs to group 18, which is a inactive, we call it inert gas or inactive gas, right? Either one means that it means that it is very stable and it is by itself. So neon gas is just Ne, it exists in Ne only. But chlorine gas, however, is a gas that exists in diatomic molecule gas. It doesn't just come with Cl. It comes with Cl2. A lot of you guys would know that group 17, not just Cl, so group 17 is basically known as also halogen, and for halogen, you know that you have F first, fluorine, chlorine, bromine, iodine, astatine, yeah. So basically, FClBrLAs, all of this group 17 or like or even oxygen, right? It exists only in diatomic molecules, which is bromine or Br2 or chlorine gas like Cl2 or oxygen gas like O2. You can never hardly you can find question to give you just oxygen, right? Or chlorine. It's very hard. unless it is in liquid or in other form, but it's in gas form, it's definitely O2 or Cl2. In this case, for this question 5, you need to calculate the number of atoms, right? You need to use 0.3 mole times 6.02 times 10 power 23. You also need to, entire equation, multiply by 2 because there is a Cl2. But when it is Ne, you only get a 0.4 times a number of Avogadro, which is a lower value lah, because 0.3 times 2 is basically 0.6, while this only 0.4. So the answer is C. So yeah, that's it. So let's go to the next question. Alright, so number 6. It says that 200 cm³ of a gas has a mass of 0.15 gram at room conditions, and what is the molar mass of the gas? So the important key point here is 200 cm³ of gas has a mass of 0.15 gram at room conditions. And what is the molar mass of the gas? Or they want to find molar mass. And this is a hot question. This is a relatively tougher question than other. So when it asks you to calculate the molar mass, there is a lot of type of molar mass. So let's identify what is molar mass. Maybe we can even do this question. So you have molar mass, I'll put mm. Molar mass is actually a combination of any of these three. It can be RAM, it can be RMM, it can be RFM. Alright? So molecular relative atomic mass, relative molecular mass, or relative formula mass. So they are looking for one of these three. But the most common one is RM lah, molecular atomic mass lah. We just find RM lah, okay? So 200 cm³ of a gas has a mass of 0.15 at room condition. So at room condition they give you already, right? It's 24. So you need to find the mole of this gas first. So 200 is giving you 200 cm³ in volume. We need to find the mole. So we know that from mole to volume, from volume to mole is actually divide by 24. Because as I have previously said and told you guys that actually when you want to convert mole to volume, you're supposed to multiply its mole to 24. Then you get the value of your volume. So now if you want to convert back, you need to divide by 24. But note that this is where a lot of students get this wrong. Because it is 200 cm³, but the standard matrix for volume is not 200 cm³, but rather it is dm³. That means we need to change it to dm³ lah. cm³ to dm³ is basically divide by 1000. So you will get I think 0.2 dm³, right? So 0.2 dm³ is basically the volume. It's basically the mole. The mole of it equals to 0.2 mole. So 0.2 mole, that is the mole of the gas. Now you're looking for the RAM. How do you find the RAM? It told you that the mass of that gas is 0.15 gram, right? So we know that by having the mole multiply relative atomic mass, you will get your value of the mass. If they give you mass and you have the number of mole, you're supposed to be able to find out the number of your relative atomic mass, because in the equation there is two constant number and one variable. Whenever in any equation in maths you have one variable, you can find out the equation. But even if you have two variables, you can also make simultaneous equation and find out the answer. But generally, in this one, you just need to know that that mole multiply the number of relative atomic mass, you will be able to get the number of the mass. So the number of the mass is given 0.15 gram, right? Equals to the number of the mole, which is, we found this now in this one, 0.2 mole, and then times RAM. RAM, we just put RM of the gas, we just put X, alright? We just put X. So X times 0.2 equals to 0.15. So X actually equals to 0.15 over 0.2. You will get a 15 over 1212 over 20. So 15 over 20, you are supposed to get a 0.75. Let's see if there's 0.75 RAM or not. Wait a minute. Something's wrong. Oh wait, 0.15 divided by 0.2. Wait, 0.75. Wait, let me see. 0.15 is 0.2. Oh yeah. I forgot to, yeah. Okay, there's something wrong here. So I forgot to divide. So the mole is 0.2. No. When you divide by 1,000 here, it's actually just equal. Okay, just sorry guys, just this mistake. 200 cm cubed divided by 1,000. That is equals to its volume. So 0.2 is not its mole. 0.2 is not its mole. 0.2 is actually its volume only. You need to find the 0.2 is volume, so you need to find the molar mass. Wait. Yeah, you need to divide with 24 again. So 0.2 divided by 24, what do you get? 0.2 divided by 24, you get 1 over 120. 1 over 120. So the number here, it is supposed to be 1 over 120. Yeah. Okay, so cancel this. So your X, it will actually equals to 0.15 divided by 1 over 120. So technically it is 0.15 times 120. You get 18. So 0.15 will bring up the 120 is actually 0.18. So the answer is A. So yeah guys, sorry, this is a mistake. I think you guys also should be cautious about this. When you calculate the number of mole, you must always remember after the conversion of the base unit. From cm cube to dm cube, my mistake was when I divide by 1,000, I thought that was the mole already. Actually no, that was still the volume when you divide by 1,000. When you divide by 1,000, it is equal to 0.2. 0.2, you still need to change it to number of mole. You still need to divide by 24. When you divide by 24, you will get 0.00833 if not mistaken, which is 1 over 120. So with that number, X times 1 over 120 equals to 0.15, and then you move it, X equals to 0.15 divided by 1 over 120, bring it up, 0.15 times 1.120, which equals to 18 gram per mole. So that is the relative atomic mass for that question. Yeah, 18. So let's go. Question, let me see which question is harder to do. Okay, let's try question 17. Alright, let's go to question 17. Let's try 17. So it's asking you what is the empirical formula of allicin, which is, I believe, the smell of garlic. And in Form 5, you are supposed to learn a chapter called carbon compound. In carbon compound, there is couple of homologous series like alkene, alkane, alkyne, alcohol, carboxylic acid, but most important thing is ester. Ester is the sweet and fruity smell it gives up in any fruits you can find, mango, like lungan, just like durian or anything, any fruit that smells like fruity or sweet smell, it is supposed to give you ester, like smell that give you the smell, but it's not fruit lah, so I'm not too sure. But generally, is what this table is. First, I'll put element, E for element, alright? And then you make a line, you make a line here, and then there is 4 element here. You have, okay, you have C, you have H, you have O, you have S. CHOS. So the second one, you need to put mass. Third one, you need to put ratio. Fourth one, you need to put simplest mole ratio or mole ratio. How we just put mole ratio, Mr. So mass, we have given the mass, and most important thing, students, you need to remember that in empirical formula questions, when they give you like the mass or its value, especially in question like this, when it's giving you the number of percentage, let's say 100%, 60% of carbon, 40% of hydrogen, the most important thing to note here, whenever you see the unit of percentage, it actually equals to the mass of the element within that compound. So 44.4% for carbon is actually 44.4 gram in this case. Let's just put 44.4. Alright, let's just put 44.4. Hydrogen, we put 6.21. O, we put 9.86. 4134, we put 39.5. Alright, so the ratio is, we get 44.4, we divide by its relative atomic mass. But in this case, you don't really have it. This is given. No, it is not given. You're not given by its relative atomic mass, but I think we are supposed to know. I think you're just supposed to know. The most special one here is probably sulfur. I think you need to remember the sulfur atomic atomic mass. It's supposed to be 32. Yeah, the others is fine. Carbon, we know, is divided by 12. So 44.4 divided by 12, you're supposed to get 3.7. And then hydrogen is 1, so it's 6.01. Oxygen is divided by 9.86 divided by 16. You're supposed to get 0.616. So 39.5 divided by 32. 1.23. So here is the special part. For mole ratio, you need to divide by the lowest number of ratio that you found previously. The lowest number among all of the elements. So the lowest number here is 0.616, right? So you divide everything by 0.616. So 3.7 divided by 0.616 is actually 6.21 divided by 0.616 is actually equals to a 10. And then 0.616 divided by 0.6 is a 1, right? So 1.23 divided by 0.616 is actually equals to a 2. So now you have the number, which is C6H10OS2. So C6H12 H12O1S2. Is there any answer in this? Yes, right? C6H10O1S2. The answer is B. The answer should be a perfect B. Alright, let's see what should we do next. Right? Okay. Number 8 is pretty easy. Skip this. Number 9 also quite normal. What is the hard one? Let me see. Is there any hard one? The following equations represent the reaction between magnesium and hydrochloric acid. The following equations represent the reaction between magnesium and hydrochloric acid. Magnesium and hydrochloric acid. So, what is the volume of hydrogen produced if you mix? Okay, this is a good question. Alright, let's try to do this, right? Let's try to do this. Is there any. There is. Oh, you actually rearrange the whole thing. Oh my god. Now, why not? What is the volume of hydrogen gas produced? So it's given the equation there. It's looking for hydrogen gas, and then it give you magnesium react. So it give you magnesium, and then you want to calculate for H2. What's 1 to 1 mole to be easy? Magnesium is giving you 3.6 gram. 3.6 gram, and then it's looking for H2. So it is looking for what? The volume. It's looking for the volume. So 3.6 divided by its molecular mass, you will find the number of mole. Number of mole of magnesium is actually the number of mole of H2 because it's 1 to 1 mole. You'll find the number of mole of magnesium, you just times 24. You'll be able to find the volume of H2. So 3.6 divided by how much is the number? Magnesium is 24. You're supposed to get 3.6 divided by 24, the number is 0.15. 0.15 is actually the mole. Since it's a 1 to 1 ratio, you just times 24 lah. Yeah. So 0.15 times 24, you get a 3.6. The answer is not mistaken, it's a C. Is it a C?